So everything we've done in Unit 2, we've dealt with inequalities that look like this. This is a simple inequality right here. Why is it simple? What makes this a simple inequality? Yeah, well, there's only one inequality there, okay? So how do you solve that? You subtract 7 from both sides, you would get x is greater than 0. Your answer is going to be 0 to infinity on that one, okay? So that's the answer to this one. This one's what? What kind of inequality? We just took a quiz on it. Absolute value. We have our strategy here is to break it into what? Two separate problems, unless this were a negative over there. If it were a negative, I would have to look and see is it no solution or all solutions, okay? So that was the case there. This is a compound inequality. Our strategy here is to do what? Yeah, break it into two problems. Here's problem number 1, and there is problem number 2. Break it into two problems, solve it, number line, pull them back together and get an interval. Same thing here. Treat this as two separate inequalities, get two answers, put them together on a number line, okay? Now, what you just saw on the quiz was polynomial inequalities. So when you looked at something like this is so complicated that the only way I expect you to solve this is by looking at a graph. So I will give you a graph. What are the zeros for this function? Yeah, -2, 0. These are points. They require an x and y coordinate. What, -1, 0, and 1, 0, okay? And then the solution to this, I'm asking for where is the graph of that function what? On the graph is where? Below the x-axis. So I saw several people doing this. This is a good strategy. That's below. That's below. How many intervals is that? That's 2 intervals, okay? So to find these intervals, you always start from left to right. As I travel from left to right, am I below the axis? Yeah, I'm below the axis until I get to what? -2. So that's -infinity to -2. How do I know what goes around the -2? Yeah, because of that being less than or equal to, that's a bracket. That's always a parentheses. And then the next interval is what? -1 to 1 with brackets around both of those, okay? So that's what we did with polynomial inequality. Now, the only thing that's left for us to do is rational inequalities. It's very similar to polynomials, okay? So I want to look at something like this, a rational inequality. Rational means fraction, okay? So a rational inequality. Before I do this, okay, there is a restriction here. How do we find restrictions on functions that look like this? You know that I can never divide by 0. So I know that x plus 5 cannot be what? X plus 5 cannot be 0. So x cannot be what? X cannot be -5. So that's my restriction on a problem like this. Now, what you're going to see is you're going to see this given to you graphically, okay? And so you have a graph of it here. So here's the function graph x minus 4 over x plus 5. What you're going to see in a graph like this, where is this line at? What is this equation of this line right here, the dark line? It crosses the y-axis, but what's the equation? Does anybody know the equation of that line? X equal -5. So this is the line x equal -5. Well, coincidentally, I know that my graph is undefined. So we have a name for this. This is called a vertical asymptote. Okay, so a big word, but really what it means is, think of this, this is a wall. My function can never cross this wall, okay? So I knew up front that x could never be -5. So what this means is I've got a line here at -5. My graph can never cross that line because this whole function is undefined at -5. So this is the equation, x equal -5. That's the equation of the asymptote, okay? Now, I just answered the same question. Where is this function less than or equal to 0? So I'm looking for where it's what? Above or below the axis? Below. Okay, so is it below the axis here? No, so it's only where? From here to right, that dot right there, okay? Okay, so now I just need to figure out what that interval is. Okay, so as I travel on the x-axis from left to right, I don't get below the axis, and I get to what? What is this point? -5. Now, what goes around the -5? Why bracket? This is a 5. The 0.4, what are we saying? The dark line is at -5. This graph is going to keep on going. See, this is going to keep on going, inching ever closer to that line. But it's never going to touch that line. Why will it not touch that line? Because the graph is what? Undefined at that point. Okay? So, I know that it's below the axis from -5, but what goes around the -5? Okay, a bracket means that my function exists at -5, and this is part of the solution. Okay, right here. Oh, sorry. I'm doing this one first. Okay, so I'm sorry. It's confused. So let's do this one. Where is it less than or equal to 0? The only place this graph is less than or equal to 0 below the axis is from this point right here. Okay, so on the x-axis, that's from -5 to where? 4. Okay, now what goes around the -5 is a parentheses because my graph is not defined at -5. So just like infinity always has a parentheses, the vertical asymptote will always be a parentheses. Okay. Now what goes around the +4? A bracket. Okay. So it's less than or equal to 0 from -5 to 4. And the reason there's a parentheses here is because this graph is undefined at that line. Now, I know I was confusing you a moment ago. Where is this graph greater than 0? So greater than 0, where does that happen? It happens here, right? And then where else? Right there. Okay, so what is the first interval here? This is from where? -infinity up to what? No. I'm on the x-axis. I'm traveling on the x-axis. I travel from -infinity and I go as far as where? -5. Okay. What goes around those numbers? It's always a parentheses on infinity. -5, what's the name for that? That's a vertical asymptote. What goes around that? Parentheses. Okay. And then where's the other point? That's what, 4 to infinity? And because this is greater than, what goes around both of those? Okay, parentheses. Okay. Pardon me? Does this go in the box as well? I didn't understand that. Uh-huh. This is the answer to this problem. Okay. And this is the answer to this problem. I'm not sure if that's, it's probably laid out a little bit confusing. Okay. Just like those other problems, I could ask you where is it greater, where is it less than? I could ask you either or both of those questions. Okay. So this is very similar to what we just did. The only thing that's added is I've got these asymptotes that show up in the equation. Okay. So let's look at this one. X, yes. Yes. Here's -5 right here. So I've drawn a line here saying that my graph will never have a value at -5. So here's the graph of the function is this. Okay. It does not exist at -5. So I've got this vertical line that's just like a wall that says my graph does not exist here. Okay. Yes, but you can only have a parentheses around it because this means does not include this number, does not include this number. The minute you put a bracket, you're saying I'm including that number, and you can't because it's not defined. So that one wasn't drawn. This one should be drawn a little bit better. So let's look at this. X plus 6 over x squared minus 4 is greater than 0. Okay. What are the zeros? And this one I have to be really clear because, so what's happening here, it's hugging this line, it's hugging this line. I have to make it very clear if it crosses. The other ones you could tell. So I made it very clear for you. What's the 0 here? Yeah, negative 6, 0. So in these kind of graphs, I'll have to be very clear for you. What are the equation of the asymptote or asymptotes? Okay, these are vertical lines. And where are they happening? Yeah, and so here's the form. This has to be x equal negative 2, x equal 2. It's an equation of the asymptote. The equation has an equal sign. So this is, if you just write 2 and negative 2, you're going to lose points. This is, the equation of the asymptote is at x equal negative 2 and x equal 2. Okay, so that's these two dotted lines that you have here. So those are lines over which my graph will never cross. My graph is undefined at those points. Okay, now what is the domain of this function? The domain is the set of all what? What values? This is the set of all x values. That's what we call the domain. The set of all x values is the domain. Okay, so if you look at this graph, what are the things that x cannot be? X cannot be 2 and negative 2. Okay, how do I write that in interval notation? If x can't be 2 or negative 2, what can it be? Not a trick question. If x cannot be 2 or negative 2, that's my only rule, what can it be? Everything else. How do I write everything else in interval notation? It's from negative infinity to negative 2, okay? And then from what? Negative 2 to 2, and then what? 2 to infinity. That's the way I write. It's everything except 2 and negative 2. Okay, that looks like a lot of writing, but all that's saying is this function is not defined at negative 2 and 2. So where is it defined? Every number other than 2 and negative 2. How do I write in interval notation every number except negative 2 and 2? That means it goes from negative infinity to negative 2, negative 2 to 2, and 2 to infinity. So that's the set of all allowed values. Yes. Why did I what? No. What I'm saying is, so my graph is undefined at negative 2 and 2. Where is it defined? Every number but that. So what is every number except negative 2 and 2? That's every number from negative infinity up to 2, every number from negative 2 to 2, and every number from 2 to infinity. This is the way I write every number except negative 2 and 2. Okay. So this first question is, what are all the valid values for x? X is defined everywhere on this graph except where you see these two big lines. So it breaks into three different intervals: negative infinity to negative 2, negative 2 to 2, and 2 to infinity. Now, where is this thing strictly greater than 0? So I'm asking, where is the graph, what, above or below the axis? Where is it above the axis? So here is a 0, so it's really sort of tricky here, but it's going, this is above the axis, and because of that dot, it crosses the axis there. So when you see something like this, a 0, like this, unless you see it go back up, it crossed the axis there. Okay, so this one is above the axis, and then where else? From here to here. How do I know what? Well, this is above, obviously. The greater than. I asked for where is it greater than 0. Okay, how many intervals do you see on that graph? 2. This interval goes from where? -6, okay? So that first interval is from -6 to where? No. I'm traveling on the x-axis from -6 to -2. This is an asymptote. That is a parentheses. What goes around -6? It's a parentheses because this says greater than, not greater than equal to. This one, yeah. Okay, we're looking for intervals on the x-axis. So we only travel on the x-axis. I'm traveling from -infinity all the way to -6. Okay, now I see where it starts to be 0. It's above the axis from -6 until I get to where? -2. Yeah, but I'm traveling on the x-axis. My intervals are x intervals. Okay, I keep traveling. It's below the axis between -2 and 2, and then it's above the axis from here on out. Okay, so these are x intervals. So from -6 to -2, that's the first interval. Now, what's this interval from here to here? 2 to infinity. And because this is an asymptote, that is a parentheses, and infinity will always have a parentheses. Okay. So what you want to do, highlighters are good for knowing this is what I'm looking for, and then either your finger or a pencil. When you go to find the interval, intervals are always traveling on the x-axis. So you can look at it, it's the interval from here to here, and this is the interval from here to here. What is that interval? That is -6 to -2. That is 2 to infinity. Okay? So you only travel on the x-axis when you're finding these intervals. So here's the big thing in this section. You know that the denominator, I don't like that color, it's too much. In rational expressions, the denominator can't be 0, okay? So you'll see a graph and you're going to see vertical lines. That tells you those are vertical asymptotes. That's where the graph is undefined, okay? And it's always going to be the form x equals some number. That's the equation of the asymptote. And then you should be able to look at the graph, identify the zeros, give me the domain, and give me information about inequalities, okay? So you guys take a look at this one just to make sure we're solid. Do I have one? I have a couple of them here. So you guys take a look at this. I'll pause and I'll work at this in a minute. So you'll find the zeros, and I should make it clear to you where zeros are. The equation of the asymptotes, there might be 1 or 2 or more. The domain of the function, and then the solution to the inequality, okay? So the equation of the asymptote, this line is at 5, x equal 5, okay? The domain, so if x cannot be 5, what can it be? Every number except 5. How do I write every number except 5? I do -infinity to 5, 5 to infinity. So that's the set of all permissible values for this function. What's the solution to where this thing is greater than 0? It's hard to see, but if it were below the axis here, then it crosses there. So that's where it's above the axis. And now what are those intervals? If I travel from left to right on the x-axis, this first interval is -infinity to -5. This next interval is 5 to infinity. Parentheses on everything because I've got a greater than, and your asymptotes always have parentheses. And then where is it less than or equal to 0? That only happens this one place on your graph. And that interval, remember the interval is on the x-axis. It goes from -5 to 5. -5 to 5. Why do I have a bracket on this first -5? Because it's less than or equal to. Why do I have a parentheses on that second one? It's an asymptote. It will always have a parentheses. Okay? One more, guys. See if you can work on this one. And then we should be able to call it a day and start the homework. So I'll work it real quietly up here. Similar to what we just did. The only difference is these asymptote lines. Okay? So in this particular problem, like I said, everything's coming off of the graph. There's really no room for algebra arithmetic mistakes. What are the zeros? So if it's not clear, I try to make it clear to you with a dot that was the only 0 right there, -4, 0. Asymptotes, these are equations. It needs to be x equal a number. X equal -3, x equal 3. The graph is undefined at those 2 points. It's defined everywhere else. So the domain is where else is it defined. How do you write every number except -3 and 3 in interval notation? So that's -infinity to -3, -3 to 3, 3 to infinity. So that's the domain of this function. Where is this function greater than 0? I shaded that in yellow. From -4 to -3, the -3 is an asymptote. It will always have a parentheses. The -4 has a parentheses because of that only being strictly greater than. And then this other interval, 3 to infinity. And then the last question, where is it less than 0? Less than 0 is from -infinity up to -4. Because it's less than or equal to, bracket on the -4. And then -3 to 3, those have to have parentheses because both of those are asymptotes. Okay? So that is it. You can go ahead and take a look at the homework, guys.